Yep. Please welcome our final speakers for today, the Cal Poly Pomona MISSA Data Analytics team. So in this talk, they'll be presenting a research topic regarding the Solarwinds hack. They're going to be talking about things like how big data is utilized in the cybersecurity field, as well as the background and the methodology of how the Solarwinds hack began. They're also going to be sharing info about some of the information that they conducted with professionals, and they will also present some interesting visualizations related to cybersecurity. So without further ado, I'll hand over the mic to Chris and Abhishek, and the floor is yours.
Thank you, Taylor. I'll be sharing my screen. All right. All right, so hello, everyone. I hope you all are doing well today, and thank you for joining our presentation. So we are the MISSA data analytics team. And like Taylor mentioned, we will be doing our presentation on the Solarwinds study case, where we will be giving you an overview, data analysis, and an industry perspective on the case. So a little bit about the MISSA data analytics team. We are part of MISSA, which is another CBA club like Swift and FAST. And our goal is to create an environment for our MISSA members to be able to talk and learn more about topics related to the data analytics field, which includes working with workshops using Tableau and Python. We host competitions like the ITC, and we also help out with projects like this project presentation that we're about to do right now. And with that being said, I will give it to Chris, and he will be giving us an introduction on our team members. Thank you.
Hey everyone. So here is our MISSA data analytics team that's going to be presenting today. On the left, we have our DA veterans, Nicholas Bias and Eric Endres. Nicholas Bias is a CIS business intelligence major. He's going to be graduating this spring. He's going to be talking about Solarwinds and provide us with some background information on that topic. Eric Endres is also a CIS BI major graduating in spring. He's going to talk about big data and cybersecurity. Nick and Eric are both going to be representing our MISSA DA team at the upcoming IT competition. And then our two members on the right here, they're new members to the team, but they came in and they really dove in with us. So we appreciate you guys for that. They're both on the InfoSec track, so we're open to anyone who just wants to come in and learn more about data analytics. They will also both be competing in ITC. Mikhail is going to be joining Nicholas and Eric with the MISSA DA team, competing in the data analytics category, and Luis is going to be competing in the cybersecurity category. Mikhail is going to talk about the attack methodology behind Solarwinds, and then Luis is going to wrap it up with some long-term analysis, and he also conducted some interviews with industry professionals, so he's going to share some footage from those interviews. So without further ado, I'm going to hand it off to our presenters here, and they're going to get started. Thank you.
All right, thanks, Chris. Evening, everybody. Hope you're all doing well. Thanks for coming to our presentation. My name is Eric Endres. I'm a part of the DA team. Tonight, we're going to be talking about big data analytics, cybersecurity, and where they kind of overlap. And I think a really good case study for that is the Solarwinds attack. So I'm just going to start out. I guess my job is to kind of give you guys some foundational, maybe some interesting tidbits here and there about both big data and cybersecurity, just to build a foundation on which then you can move on to understand the Solarwinds attack better. So I'm going to start out with big data. Going all the way back to 1880, the American census generated so much data that they figured out it was going to take them around 8 years just to process all of it. Considering a census happens every 10 years, it wasn't very functional for them. So a man named Herman Hollerith created a tabulating machine, which you see on the left here, based on punch cards that were used for loom machines. He actually cut down that processing time to 3 months. Now we're going to jump at 66 years to 1946. Something called the ENIAC is built by the US Army. That's the center picture right there. It was mostly used just to store defense codes, and it wasn't technically a data center, but it is the idea of storing a lot of data is there. We're going to jump to 1965 when the US Army actually builds the first data center, and that was used to store fingerprint sets and tax returns. Now we're going to jump a little further. 2005, the word big data is actually coined by a man named Roger Muglis. He was the director of market research at a place called O'Reilly Media. And when he said it, he was referring to the amount of data that they had collected being completely unmanageable, very hard to keep track of and use with real value. During that same time, Apache created something called Hadoop, which is the first big data architecture. They used Google's MapReduce software. And this, one of the big things about this is that it could process both structured and unstructured data, which we're going to touch on in a little bit. Slide, please. Now let's get into the basics of big data. The more things we measure, the more data we're going to be collecting. And as you guys know, it's a constant evolution. We're generating more data now than we ever had. It's exponential in its growth, and wrangling it and making sense of it is one of the hardest things to do with that amount. At its core, big data uses these huge amounts of data combined with really strong analytical and statistical tools to either describe, explain, or predict things that are going on. So let's talk about the big five. These are core to what big data is. The first one is volume. It's how much data are we talking about? Originally, maybe not that much, but when we're talking, let's bring up Instagram as an example. One photo upload has a max 10 megabyte file size. And there's around 95 million of those photos updated every single day. So that's around 950,000 gigabytes just of photos, just on one app. So it's how much data are we actually using is very important. The second V is going to be velocity. How fast is this data coming at us? With upgraded hardlines and Wi-Fi capabilities, it's coming faster than ever. Veracity is another big one, and it regards the accuracy of the data. How accurate is that data that we're using and getting in? If it's not accurate, some of the analysis that we're doing is not going to be that helpful for us. Variety is also another huge one, and that has to do with what type of data are we talking about. You have images, text, numeric values, categorical things. They're all being updated simultaneously, sometimes multiple forms of data on one upload. An example of this might be a YouTube video. You have your video data, you have your comments, you have your likes, dislikes, follows, unfollows, all types of data stored in one little thing. And lastly, the last V is going to be value. How valuable is this data to our corporation or business? It has to be valuable to our analysis in order to justify spending the money on collecting it and storing it. Just quickly, there are really two types of data. Structured is the original, like traditional type of data, and it's usually stored in tables where you have a central fact table, and then you have some dimensions that are related to it. Those were stored in like physical data warehouses. They are still in use, but more commonly, because of the escalated volume of data, we're getting into unstructured data territory. This is free flowing, and it's a lot like social media data, all that kind of stuff. Because of the amount and the size, these are usually held in things like data lakes, which are on the cloud, on a cloud infrastructure. Some quick statistics, 2.5 quintillion bytes of data are generated every single day. Big data as an establishment is estimated worth of 77 billion by 2023. So there's a lot of money coming into this industry. And around 45% of companies are using big data in the cloud, which will be important later. Just a few real life examples of big data use are healthcare. They use it for things like the COVID mapping, testing treatments. Utilities might use it for use patterns to avoid power outages. And for everyday use, you might know big data in forms like Nike apps, like fitness apps or Fitbit, or if you use Spotify, they actually use a lot of big data to track things like the emotions of current listeners. It's also heavily used in cybersecurity, which brings me to my next slide. Just a little history on cybersecurity. I'll try and go quick. 1950s, some people called the phone freaks who knew hardware things about phone lines started using that to get free long distance phone calls. Not super malicious, But hey, if you're getting a free phone call, you're getting a free phone call. We'll jump up to when the ARPANET is being used. You'll see here on the left, a guy named Bob Thomas, who is a researcher on ARPANET, created a small little bug called the creeper. And what it would do is worm its way around little files and say, it would just leave a little breadcrumb that says, I'm the creeper, catch me if you can. Another ARPANET researcher named Rob Toblin, who also happens to create the email later on, creates something called a Reaper to find, track down, and delete that creeper. This is actually really interestingly one of the first cases of an antivirus, as well as a self-replicating worm. So at this point, obviously, it's not super malicious, just seeing what we can get away with. But you get up to 1986, and a man named Marcus Hess uses the ARPANET, and he actually hacks into military machines, including some in the Pentagon. His intention was to sell some of the data that he was harvesting to the Russian government. It becomes very clear at this point that cybersecurity needs to be paramount in a lot of these huge organizations. You get into the 80s and the 90s, the battle of the antivirus softwares goes on. McAfee is actually one of the first. And as these antivirus measures evolve, so do the attacks. It's like playing a constant game of whack-a-mole. You put out one fire and 3 more will start as these attackers find more and more exploits. Attacks, as you can see, they started with some hardware exploitation to networking. They got into software and operating systems. Then they get into Trojans and viruses, things that we probably remember from our youth. And now today you have things like zero-day exploits, phishing, and ransomware. Ransomware has become very popular. It gets in and will encrypt your data, and it will charge you to get access back to that data. There's some money to be made when you attack normal everyday users like you and me, but the big money is going to be in businesses, companies, hospitals, infrastructure, things that are crucial for the operation of our society. People will pay to make sure they keep that functioning. And just as these attacks have evolved, they evolve because of where attackers are evolving. Attackers, they change their goals. Sometimes it's not just money. Sometimes it's about hurting the other team. And according to FireEye, there are around 30 plus of these things called advanced persistent threats, which are APTs. Most of them are likely state sponsored. So now I'm going to talk a little bit about overlap. Where do these two things come together? Big data can be used in something called network behavioral analysis. And what this does is it looks at data over long term, huge amounts of data. And what that allows you to do is detect outliers or anomalies that have a pretty high likelihood of being attacks. You can also use big data as attack prediction. If you can see where things are attacking and what types of attacks are being used, you might be able to then predict where it might be attacked and how it might be attacked next. One of my favorite things is threat visualization. You can get a dashboard that shows you where attacks are actually happening right now, where is it coming from, and how are they used. I'll actually touch on this a little bit later. And also pen testing. Data can be used by pen testers to see where their systems might be more vulnerable. Now that you understand some basics of both big data and cybersecurity, I'm going to hand you back to Abhishek, who's going to be showing you a pretty cool big data dashboard of cyber attacks.
All right. So can everyone see my screen? Okay, so for this dashboard is from informationisbeautiful.net, and this is basically the world's biggest data breaches and attacks, like cyber attacks. And as you can see here, we have many big companies like Microsoft and Facebook. It goes by the year. So for example, we're in 2020, and the earliest it goes back until is 2004. And as you can see, in 2004, we see that we don't really have as much cyber attacks going on in these years. But as we go until 2013, 14, 15, all the way until 2020, we see more attacks on bigger companies. This dashboard, it shows us, for example, the company, it shows us the number of breaches. It's going to show you the month and the year. It'll give you like a little summary. And this is just an extra bonus. If we do click here, it will take us to an article on the data breach. And another company we have is a Solarwinds company. So it happened December 2020. It's a small summary and an article on that data breach. And another thing we could do with this dashboard is we could also filter it. So we can filter it based on different sectors within like academic, finance, gaming, for example, and we could filter it by the different methods. So hacked. And we can kind of play around with it. We can kind of see which sectors we want and which type of methods we want and get in more data that way. And lastly, the orange circles they're just more of like interesting stories that were recommended. And yeah, I guess so. With that being said, I will give it to Nick, and he will be talking about the SolarWinds case.
Hi, everyone. So Solarwinds is an American company that develops software for businesses to help manage their networks, systems, and information technology infrastructure. Next slide, please. They try to make their products as simple as possible to make jobs easier and for possible end users who have no IT experience. They are a leading provider of powerful IT infrastructure managing software. Their products give organizations the power to monitor and manage the performance of their IT environments, regardless of the type, size, or IT infrastructure complexity, whether it's on-premise, in the cloud, or hybrid models. They create products that address IT management needs in ways that align with how today's technology professionals work on a day-to-day basis. And this focus on the users in end-to-end hybrid IT performance management has established SolarWinds as a worldwide leader in network and systems management software and MSP solutions. Next slide, please. So one of the products SolarWinds provides is SolarWinds Orion. And this platform makes it easy to monitor, analyze, and manage the complete IT stack in one place. SolarWinds describes the Orion platform as a powerful, scalable infrastructure monitoring and management platform designed to simplify IT administration for on-premise, hybrid, and software as a service environments in a single pane of glass. So there's no need to struggle with multiple incompatible point monitoring products, as the Orion platform consolidates the full suite of monitoring capabilities into one platform with cross-stack integrated functionality. Next slide, please. So the Orion platform monitors the health and performance of a network through internet control message protocols, simple network management protocols, window management, instrumentation, application programming interface, and Silog communication and data collection. Next slide, please. So for an Orion platform deployment, there are two servers that are needed. The main Orion server, where you install the primary server, which includes the main polling engine and the Orion web console, and a separate server to install the SolarWinds Orion database. The polling engine requests real-time statistics from monitored devices in your environment. And then polled data is further processed and stored in the SolarWinds Orion SQL database. Data is requested from the database and displayed in the Orion web console. Next slide, please. And as we can see here, everything is connected to the SolarWinds Orion server. You can see that there are switches, other servers, and routers from the business network that are all connected to the SolarWinds Orion server. Next slide, please. So, SolarWinds products serve more than 275,000 customers worldwide. And as we can see from this slide, there are a lot of big name customers here. The Pentagon is the biggest customer, with the Army and Navy being big users. The Department of Veteran Affairs, which is heavily involved in the US response to COVID-19, is another Origin fan and the biggest spender on the tool in recent years. The National Institutes of Health, the Department of Energy, the DHS, and the FBI are also amongst the many branches of the US government that have previously bought the tool. But it's not just the government. They're also in the private sector. SolarWinds Orion also provides to 425 of the Fortune 500 companies, all major US telecom providers, the top 5 US accounting firms, and hundreds of global universities. Next slide, please. So this is why this breach is such a big deal. And as the CISA acting director Brandon Wales said, the compromise of SolarWinds Orion network management products poses unacceptable risks to the security of federal networks. Next slide. So who do we blame? Not much is known about the attackers right now, but the main suspect is the Russian cyber spy group known as Cozy Bear, or Advanced Persistent Threat Group 29, which are a part of the SVR arm of Russian intelligence services. Next slide. So here is what the Orion web console looks like. And the attackers attach their malware to a software update, which will be explained in detail later. But the SolarWinds Orion web console automatically notifies users when there is an update, as we can see here in this bell icon in the top right. The update is a standard Windows installer patch file that includes compressed resources associated with the update. And you need specific credentials to use specific functions in Orion. Next slide, please. So next I'll be talking about FireEye. And FireEye is responsible for discovering the SolarWinds hack in December 2020. And according to their website, they have been involved in the detection and prevention of major cyber attacks and provide hardware, software, and services to investigate cybersecurity attacks, protect against malicious software, and analyze IT security risks for customers like SolarWinds. Next slide. So they have this new approach that they've created called FireEye Adaptive Defense. It delivers technology, expertise, and intelligence in a unified, nimble cybersecurity framework. And their technology protects customers with their virtual machine detection engines that can find cyber attacks that bypass signature-based tools and common sandboxes. Their security expertise comes from fighting the most skilled, persistent threat actors, which allows them to resolve data breaches quickly and prepare for future attacks. Their threat intelligence blends threat data from millions of virtual machine detection engines around the world with the vast expertise of their expert cybersecurity analysts. They hunt for new attacks, tools, and methods to keep a business's defenses up to date. So FireEye Adaptive Defense can detect cyber threats other security tools may be missing in minutes and not months. It can prevent many cyber attacks instantly and stop complex attacks before they cause lasting damage. It can analyze network traffic, files, and endpoint activity for a full view of your environment. And it can know what systems are affected and understand the impact. It can also respond quickly to attacks to reduce incident response times, and it can get the details and advice that businesses need to remove the threat without disrupting operations. And finally, adaptive defense constantly evolves. It learns and improves to deal with new cyber threats. Next slide. And so I'm just going to finish off my section with some quotes. And according to Dan Wire, who's FireEye's Vice President of Global Communications, when asked how was the hack discovered, he said, "We're still investigating. No promises, but I'm hopeful we'll be able to share some of the attackers' tactics, techniques, and procedures on how we detected the attack down the line. For the moment, we don't have anything specific to share." And then there's this quote by Charles Carmichael who says, "We looked through 50,000 lines of source code, which we were able to determine there was a backdoor within SolarWinds." And I just want to end with this link right here for everyone to look at. And it's by FireEye, and it shows what kind of attacks are happening and where they are coming from and where they are aimed at. And you can get a link in the chat for you to see it yourself. And this is all happening in real time. And you can constantly see usually Russia or China attacking the US at many points. And That's all. So now I will pass it along to Mikhail to talk about the attack methodology.
Hey, Mikhail, you're on mute.
Sorry about that. Hello, everyone. Once again, thank you all for attending. My name is Mikhail, and I'll be going in depth on the various attack methodologies used in the infamous Solarwinds hack. Sun Tzu, a military strategist from the 5th century, once said, "All warfare is based on deception." And this philosophy remains pretty relevant to this day. So to begin, let's look at 3 types of warfare and get a good idea of which incorporates the most deception. The first of which is kinetic warfare. Fortunately, the US has been able to steer clear of direct kinetic warfare since 1945, which marked the ending of World War II. Next, we have economical warfare. Economical warfare is fairly prevalent today due to trade deals, sanctions, and tariffs. These definitely play a role in international stability on a day-to-day basis. However, informational warfare is a topic which is rising in importance at a similar rate at which our adversaries are gaining more cybersecurity and hacking knowledge. Therefore, it is very important that we address the issues of how information must be secured and the dangers of what happens when information is exploited, such as the Solarwinds hack. So for reference, let's look at the Solarwinds attack timeline. So if we look at the first day on our list, September 4th of 2019, we can see the threat actor access Solarwinds. The date of which the hackers first accessed Solarwinds was unknown for a while. However, this past January 11th of 2021, the Solarwinds CEO, Kevin Thompson, disclosed that September 4th was in fact the date. And if we go on about a week later, on the 12th of September, we can see the threat actor injected test code and began a trial run. This ran for about 2 months and lasted until November 14th, as we can see on the next day. So moving on a bit to the next year, just around when things got a bit crazy, on February 20th of 2020, the Sunburst attack was compiled and deployed on February 20th. And if we go on to the next day of March 26th, we can see Solarwinds released their update to Orion called Hotfix 5 DLL. The security fix addressed the disclosed security vulnerabilities prior that Orion had. And we can go a couple months later on June 4th, and we can see the threat actor removed malware from the old VMs. Now, for about 10 months from February on December 12th, 2020, we can finally see that Solarwinds is notified about Sunburst. During a FireEye breach investigation, FireEye discovered that Solarwinds Orion updates had been corrupted and weaponized by hackers. This was found out on the 11th, and a FireEye executive advised the Solarwinds CEO, Kevin Thompson, that Orion contained a vulnerability as a result of the cyber attack. So if we just see a couple days later, on the 14th of December, the software company disclosed the breach in an SEC filing, and shareholders and customers were notified. Around this time, shares dropped about $20. And now if we go on just one day later, we can see that Solarwinds released a software fix. On this day, a lot of things happened. A bipartisan group of 6 senators wanted the FBI and the Cybersecurity and Infrastructure Security Agency to submit a report to Congress about the impact of the Solarwinds cyber attack on agencies. The lawmakers wanted answers to 6 questions, including how many agencies were impacted, how the FBI and CISA worked together to address the attack, and if agencies failed to implement FISMA or any other cyber laws. The senators also wanted an additional briefing of the topic as well. So now on the 17th of December, we can see a US CERT alert was issued. For these next couple of weeks, towards the end of the year, it was discovered who had been compromised exactly, and numbers were alarmingly high, and fingers generally pointed to Russia, as the complexity of the hack seemed to be the work of a nation, as my teammate Nicholas stated in his previous slide, but it's still unknown. Yeah, and we can see on January 1st, 11th of this year, new findings were related to Sunspot, and let's kind of go more in depth on how this hack went undetected for such a good portion of this timeline, because Sunspot is an integral part of that. So Sunspot, the root of all this. Sunspot was identified on a disk with a file name of taskhost svc.exe and internally named taskhost.wexe by its developers. It was likely built on February 2nd, 2020, according to the build timestamp found in the binary, which is consistent with the currently assessed attack timeline that we just previously went over. So Sunspot is malware used to inject the Sunburst backdoor into software builds of the Solarwinds Orion IT management product. We'll get more in depth onto the significance of Sunburst in a bit, but for now, let's keep talking about Sunspot. Sunspot monitors running processes for those involved in compilation of the Orion product and replaces one of the source files to include the Sunburst backdoor code. Several safeguards were added to Sunspot to avoid the Orion builds from failing, potentially alerting developers to the adversary's presence. This is yet another factor for how this went undetected for such an extended period of time. And we can see right here on the slide the significance of Sunspot. When Sunspot finds the Orion solution file path in a running msbuild.exe process, it replaces a source code file in the solution directory with a malicious variant to inject Sunburst while Orion is being built. While Sunspot supports replacing multiple files, the identified copy only replaces a file called inventorymanager.cs. The malicious source code for Sunburst, along with target file paths, are stored in encrypted blobs and protected using the same key and initialization vector. So now let's get more into Sunburst. Right there on the top left, we can see that Sunburst is a Trojanized version of a digitally signed SolarWinds Orion plugin called solwinds.orion.core.businesslayer.dll. This allowed for the Orion update to affect so many different agencies, companies, and individuals on that date where the update was released. On the bottom left, we can see the plugin contains a backdoor that communicates via HTTP to third-party servers, which is another key technique that these hackers used to their advantage. And in the top right, we can see the backdoor uses multiple obfuscated block lists to identify processes, services, and drivers associated with forensics and antivirus tools. This takes place during an initial reconnaissance prior to when any data is stolen, so the hack is aware of its environment and steers clear of any adversity it might face. And on the bottom right, we can see the topic of complex data extraction that Sunburst provides. The malware's network traffic attempts to blend in with legitimate SolarWinds activity by imitating the Orion Improvement Program protocol, and persistent state data is stored within legitimate plugin configuration files. So essentially, when data had begun to be stolen, all infected computer files were not stolen. Small amounts were stolen at a time, and the stolen data is then encrypted and wrapped in legitimate data. Most IT professionals probably did not notice any data leaving their networks due to this looking like normal SolarWinds traffic. Yet another reason why this hack was very well made and went undetected for such a long time. So if we just look at our next slide, we can see kind of three key attack methods that made this so successful. First, which being this hack incorporated techniques of a supply chain attack, which is why the span of it was very wide and affected hundreds of organizations and agencies. Secondly, we can see the 2-week dormant period was a very nice touch, as the update, like when it was installed, you would have to wait 2 weeks to notice anything. So even if it was installed in a quarantine environment, monitored 24/7, you would not notice anything for 2 weeks. And lastly, the technique that we just went over, the encrypted extraction, was a really nice touch as well, as this proved to be a strong technique that went under the noses of many IT professionals for months. So these three attack methodologies contributed to the large amount of victims affected in such a long period of time, all while being undetected.